Okay, we're going to start the last section of our waves unit, and that's going to be with a look at seismic waves, earthquakes, and tsunamis. So go ahead and get your notebook set up. We're going to do tell me mores on the left, tell me mores on the right, and big ideas on the left. See if we can get this going here. Big ideas, and tell me mores. And you can call it earthquake and tsunami notes. So an earthquake is basically when the plate tectonics, the plates of the earth, are moving past each other and they kind of get stuck. When they get stuck, they're trying to keep moving, but they can't because the rocks are stuck on each other. They're going to keep moving, keep moving, keep moving, keep moving until they finally snap. And when those rocks break or snap or finally move, they release an enormous amount of energy. And that's what we feel as an earthquake. And that energy is sent out in the form of seismic waves. Now, most earthquakes occur along the plate boundaries of the earth. So we know that Earth's crust is divided up into a series of land masses that we call plates. And those boundaries around the plates are where most of the action happens. So here, if we look at the Pacific plate, which makes up the majority of the Pacific Ocean here, it sits right up against the North American plate here. And this is where we get all of our earthquake and volcanic activity. So the Pacific plate is subducting underneath or going underneath of the North American plate, which causes us to have our earthquakes and volcanoes out here. It's also sliding upwards here, so this is where California gets its seismic activity. You notice Japan here is on the ring of fire, which we call this. Ecuador, where the large earthquake that just occurred this weekend was affected by this plate here. So lots of active areas of the earth. So we're just going to look at a little bit more detail at what an earthquake is and what seismic waves are. So earthquakes, like I said, generally occur along the boundaries of the plates. And those plates come in a couple different types of forms. As we mentioned, our plates activity here is due to a subduction zone. So here, this could be the Pacific plate subducting under the North American plate. It forms a trench here at the subduction zone. Here on ours, we have what's called the Aleutian Trench, which is underneath the water that we have out here. Also tends to create volcanoes along the edge there, which we get across which we have across the inlet. Redoubt and Iliamna and Augustine were all formed in this way. Another type of boundary is also called a convergent boundary, but it's a collision convergent boundary. And this is the Himalayas were formed this way. So when the two plates come and collide, and one doesn't go underneath of each other, they collide, the ground kind of crumples up and folds up, forming mountain ranges along its edge. A divergent boundary, divergent means away, pull away, occurs when the two plates are spreading apart from each other. The really big divergent boundary that we have here on Earth is the Mid-Atlantic Ridge. So if you look down the middle of the Atlantic Ocean, you'll see actually a visible ridge where the boundaries or the plate boundaries are pulling apart from each other. And then finally we have the transform fault. That's where two plates are sliding past each other like this, kind of like the California coast. Earthquakes are formed this way. The faults are actually the cracks in the crust where the earthquakes occur. And again, they're most common around the fault boundaries, but they occur elsewhere as well. And there's a few different types of fault boundaries that you can see. The first is a reverse fault, and that's where the one piece of the crust pushes up against the other one. A normal fault is where the piece pushes down. And then a strike slip is where they're sliding past each other like this, horizontally. So 3 different types of faults that are out there. Some more vocabulary words. Now we're going to be looking at the earthquake itself and the energy that is released during an earthquake. So the seismic waves are just like any other waves. They're caused by a disturbance. Again, this is the sudden release of energy when the earthquake occurs. And they travel just like any other waves. The energy travels out in the form of waves. And we'll look specifically at what types of waves are generated in just a minute. A couple of words that come up often when you hear about earthquakes in the news are the earthquake's focus and the earthquake's epicenter. Most often, people are concerned about the epicenter. The epicenter is the point on the Earth's surface, like on the map, where right above where the earthquake actually happened. Where the earthquake actually happened, where the rocks actually broke and split away from each other, is called the focus. The focus is the actual point where the energy release or the disturbance happened. The epicenter is the point on the Earth's surface that we can mark on a map, saying this is where it occurred, directly above the focus. And the seismic waves are sent out or released, travel out away from the focus. So let's look at the different types of seismic waves, because believe it or not, there's actually more than one type of seismic wave. It's not just an earthquake happens and one type of wave happens. There's actually a few different types. And they all fit into two categories. The first category is a body wave. And it's called a body wave because it can actually move all the way through the Earth, down into the interior of the Earth. And there are two main types of body waves, the P waves and the S waves. P waves are called P waves. They're called primary waves, but abbreviated P waves. And these are the first ones to arrive, hence the name primary. So when an earthquake happens, the primary waves are the first ones out. They're fast. They can move all the way through the solid Earth and the liquid parts of Earth. And they also travel as a compressional wave. So when they travel, you get the Earth being squished and stretched as it moves through. Directly following the primary waves are the S waves, or the secondary waves, and I don't know why I didn't write it in there. They're a little slower than the P waves, which is why they come after, and they actually travel as transverse waves. So instead of moving the medium with the energy of the wave, they're going to move the medium at right angles, so you get a little bit more of that rolling that occurs. Now, one cool thing about S waves is that they can only travel through solid rock. So even though they go down into the interior of the Earth, they can only travel through the solid parts. So it's one of the ways that scientists confirmed that the outer core is liquid, because S waves don't go through the outer core. They're stuck. The other category of seismic waves are actually called surface waves. The surface waves come from the fact that they can only travel along the Earth's crust, right along the surface of the Earth, which causes them to be the most damaging and destructive of the earthquake seismic waves. So they generally arrive after the body waves. You get P waves, S waves, and then the surface waves show up. And like I said, most of the damage actually occurs because of these waves. We can break them down into two categories, and both types of waves are actually named after the person that first described them. The first one was described by Mr. Love. It doesn't have any romantic connotations. It's actually his last name. And he was a mathematician, and he described the behavior of these seismic waves that follow the S waves. They're definitely the fastest of the surface waves, and they actually move in horizontal motions. I always think of it like the way a snake slithers. So here it's moving like this instead of a transverse wave, which moves up and down. So really interesting. Sometimes you can see displacement on the Earth's surface because of love waves, where roads or something get away from each other sideways, and that's because of this horizontal motion. Rayleigh waves, actually named after Mr. Rayleigh, who described them as well, actually move the ground sort of like the waves on an ocean. And this is often people who have experienced large earthquakes, like say the 1964 earthquake, will say that the Earth was rolling like the ocean. And this is the Rayleigh waves that they're describing. They are often the most damaging because they're often the largest wave that is generated by an earthquake. So finally, I just want to briefly mention tsunamis because, of course, tsunamis are waves, or they're a series of waves. They're actually caused by some sort of out at sea, so they can occur in a lake as well, earthquakes, out at sea disturbance. It's mostly earthquakes, definitely can be landslides, which we'll look at a big one that occurred here in Alaska, and often volcanic eruptions can cause them. So you need some sort of large displacement of water sending out an enormous amount of energy to create a tsunami. Really important to remember that tsunamis are not tidal waves. They're often mistakenly called tidal waves because when they come in, they appear to be like a sort of a really fast rising tide. So people call them tidal waves, but they have nothing to do with the tides at all. It's more accurate to call them tsunamis, which is the Japanese word meaning harbor wave. They're also very, very different from the types of waves that we normally see on the oceans, the ones that are caused by tides and by wind. And the one major difference is that their wavelengths are really, really long. And that can cause the periods that the wave or between the waves occurring, to actually last anywhere from a few minutes to a few hours. So people that are experiencing these large tsunamis often have a continuous inundation by them, causing quite a bit of devastation and destruction along the way. So tsunamis are a series of waves that are generated by some sort of disturbance out at sea, usually an earthquake that occurs under the sea, where once it occurs, that seismic wave, that energy is released, displacing an enormous amount of water, sending them in. If you were a boat out on the ocean and a tsunami occurred, you may not even notice that it actually occurs. What happens is as they get closer, just like any other wave, as they get closer and the ground gets shallower, the water gets shallower, the waves get stacked up on each other, causing their height to rise. This is kind of a mistaken picture. You usually don't see them crashing in like that, like a big white wave. Like I said, they usually come in as almost a rapidly rising tide, but it's kind of a good diagram anyway. So the wave height often gets much higher as they get closer inland, which also causes so much destruction. So make sure you get all your notes taken care of, and you can move on to the practice after this.